Vector applications, and we are considering velocity at the moment. So the question which we took, I'm just extending that problem so that we understand most of the scenarios which we are going to deal with in such applications, right? So most of the problems when we talk about velocity, relative velocity, we are dealing with wind and air speed, airplane speed that means, and or it is water and boat speed. So I've taken this example on boat and river, and I've given you a question later which is plane and air. So you can solve that question based on what we are discussing now, right? So here is an extension to the previous question. So the first part of the question is same, the situation that is. So the question here is, a river is 2 kilometers wide and flows at 6 kilometers an hour. Anna is driving a motorboat which has a speed of 20 kilometers per hour in still water, and she heads out from one bank in a direction perpendicular to the current. A marina lies directly across the river from the starting point of the opposite bank. So part C, we have already done A and B in the previous video. Part C here is, if Anna decides that she wants to end up directly across the river at the marina, in what direction should she head? What is the resultant velocity of the boat? So that is the question. So now we have the same situation as it was in the last case. So we have a river here which is 2 kilometers wide. So that's the distance, 2 kilometers. And Anna is going on a motorboat which she drives at 20 kilometers an hour in still water. And during this time, the speed or the water current is 6 kilometers an hour. And Anna decides that she wants to end up directly across the river. That means she wants to start from here and end up right across. So let's say Anna wants to start from here and want to end up here at B, right? Then of course, if that is your final point, she has to head in this direction, some degree theta. And then because of the water current, she will end up right there, right? So let this point be C for us. So she heads out in this, effectively, the boat, because of the river velocity, lands up right across, right? So we need to find the direction in which she heads and the resultant velocity of the boat, right? So that is the question. I hope you understand. So our strategy is plain and simple, just as we did last time. So we will make two diagrams here. So one we call it velocity diagram and the other one is the displacement. Now as you appreciate, velocity and displacement are directly proportional. Higher the velocity, more the displacement, right? So a very similar triangle will be made for displacement also, right? So both the triangles are actually very similar, right? So if we say that the velocities make an angle of theta, then the displacement will also make the same angle theta. That is what I'm trying to say here, okay? I hope you understand that point. Now let's start the problem. So this is the location of Anna. She heads at an angle of theta with the velocity of 20 kilometers an hour. And because of the water current, which is 6 kilometers an hour, she lands up right across at B. So we have to find this angle theta. So now from the diagram, this is simple. We can use sine of theta, right? So we know sine of theta, which is opposite over hypotenuse. This is the right triangle, correct? Opposite over hypotenuse, which is 6 over 20, right? That is sine of theta. So from here, we can find what theta is. So we say, well, now from here, this implies that theta equals to sine inverse of 6 over 20. And let's use calculator to figure this out. So sine is the second function. Sine inverse of 6 divided by 20 is equal to 17.45. So we can write this as approximately 17.5 degrees, right? So we rounded 17.45 and so on as 17.5 degrees. So we get the first answer. What direction should she head? So direction is from this horizontal 17.5 degrees. Now the second part is, what is the resultant velocity of the boat, right? So in still water it was 20. What is this final velocity, right? It looks like lesser than 20 from the diagram itself. So let's find it out. So for finding this out, we can use Pythagorean theorem, right? So these are the three sides, hypotenuse. So this side AB will represent the velocity of the boat. So we say AB square, or we can say AB is equals to square root of hypotenuse square, which is 20 square, minus opposite side square, which is 6 square. So that gives us AB, right? So if we use the calculator, 20 square minus 6 square equals to, and square rooted, we get our answer as 2 square root 91, which could be rounded to 19.0787. So I'm writing this as approximately 19.08, right? So that is the velocity, correct? Now since units of velocities are given as kilometers per hour here, let's put it kilometers per hour. So that becomes the velocity with respect to ground, right? So now let's try to see the situation. Effectively, what will you see? If you are standing here at A, let's say, then you'll see a boat which is actually nose is towards sea, right? So you'll see a boat whose nose, let me show it like this. Let's say this is our boat whose nose will be pointing towards sea, but actually it will be moving horizontally towards B. Do you understand? Let's say this is the boat direction. So because Anna heads in this direction, when you see from the ground, you will see that the boat actually is pointing like this, but going right across. That is how. And so Anna will land from A to B with a relative velocity of 19.08 kilometers per hour, and this heading, this direction, is 17.5 degrees from the horizontal. So that is how you're going to see it, right? So I hope you appreciate, one, how easy it was to solve the problem. Second, I try to give you how it will really look when you see it, right? So sometimes we can ask you a problem that boat is directed at an angle of 20 degrees and is moving horizontally. That means what? That means that the intent was to move in this direction, and the resultant was that it was moving horizontally right across. Do you like it? So that is how it is. So one part is doing the problem, second is understanding, visualizing and appreciating. I hope you got all the experience in this, right? So with this, we'll move on to a practice problem for you, and I hope you will be able to do it yourself. Thank you. Thank you, Gautam, once again.